recording. Excuse me. And so let's hear some thoughts about the thing. Let's Jamie, what y'all talk about?
We talked about how just sort of not easy to read, I guess this list is.
Yeah, agree.
How it is. I mean, and I think if I were to write out by hand like a grocery list, I'm not going to write like tortilla out 7 times. I'm going to say like tortilla 7, just like you would if you put it into a hash.
Totally. Yeah, this is like the contents of my refrigerator almost. The problem with buying with things in Amazon is you're not really sure how much you're going to get sometimes. So the amount of tortillas I have in my apartment right now, one would probably describe as concerning at the very least. Let's hear from Ryan. Ryan, I'm presuming hopefully you're in a different group. I'm just picking people at random. Are you in a different group? Yeah. Yes. Let's hear what y'all have to talk about.
Oh, just that it would be easier to store that amount of tortillas in a number form and have the tortilla be the key to it. It's just quicker.
We could store things in such a manner that would be nice, wouldn't it? What I'm doing is we're kind of alluding to the hash, and why is there 33 is not part of this class. That was just for some reason that was there. And so what I would say is a hash. Is this large enough for everyone? Would we like it bigger? If you would like this bigger, it is okay to make things bigger. I'll continue until there are objections. A hash is a data structure used for representing a collection of things. And this is I would say, a relatively vague description of what a hash is, because at the same time, could we not also use the description to describe an array, right? Is not an array also used to represent a collection of things, right? The difference is that an array represents, and this is in general, a list of ordered indexed values. Ozzy, what do I mean by ordered and indexed?
Just that, like the ordered map, it's this very specific location where you're going to find each element. Versus like a hash, you can call out any hash in any order.
Let's not talk about hashes, right? We're just talking about we're just going to speak about arrays by themselves. And we've seen this behavior with arrays before. It's like when you put something into an array using like the push method or say the shovel operator, like it goes in the first slot and the next one you add in goes in the next slot and so forth. And then we access these things by using their index numbers. Like we start with 0, the next one is with 1, and the one after that is 3rd, and so forth and so forth. We could do things like shift, which will pop the front one off, and then everything kind of slides over into a number. And this is like, yeah, this makes sense. I think that like as we first learn how to program, arrays just are very, very easy to kind of conceptualize and visualize in our heads, right? Like we can all think about like the various real life analogs we have to raise. Like when we think about like a subway, like a subway train with the cars. Like there's a first one, there's a last one, some cars in the middle, and we can take the first one off. We can do all these things. And I don't know why, but this one kind of sticks to me. You ever go to like a buffet and they have that thing that the plates go in, and you can only grab like the top plate, and that's the last plate in. Like this kind of like this idea of the stack of plates that it's kind of on a spring. Am I totally in left field, or do y'all like kind of know what I'm talking about? Right. A good number of you give me a thumbs up, right? And like that operates very similarly. Like there's an order to them. Like if the plates are separate colors, then like, well, maybe the first plate is blue, or the 5th plate is red, and so forth. Like in my mind, I think that in our minds, I think it is natural for like humans to kind of crave like this order and structure to our data. And an array is something that makes sense to us intrinsically. Like we think about things in a line, like in that word. If you're English, people stand in a queue, right? This is all there's a very physical analog to it, and it makes sense to us, right? However, when we talk about a hash, it represents a collection of named values. These named values are called keys, and each key has a corresponding value. Right? So the big difference here between a hash and array is that when you shove something into an array, it takes like the lowest numbered slot available, right? So like if you have two things in an array and you add something to it, and usually we add from the back, that new thing that we've added will be an index 2. Yes, 2, right? That makes sense. However, hashes live in this kind of other place where we don't deal with a number, we don't deal with order, they are attached to keys. And so that's like saying, like, so in my screen right now, Jamie's in the upper left-hand corner, then in the first row, then me, then Matt, then Swayze, then Henry, right? I could say, like, Jamie's in slot 0, I'm in slot 1, Matt's in slot 2, Swayze is in slot, I've already lost count, 3, and Henry's in slot 4, right? And that's like an array. But a hash, I would say, like, no, Jamie's in slot green, I'm in slot couch, Matt's in slot puppies, Swayze is in slot kittens, and Henry's in slot water bottle. And these are keys, and I'm just picking random things and that are popping in my head, and like this is the chaotic part. There is no order to this. We are assigning like code names or addresses, right? And so like this is the data structure called a hash. Some languages call hashes dictionaries, and I really like this idea of using the term dictionary, because I think that in my mind it makes sense. In a dictionary, you have words and their definitions, and we can draw that parallel with hashes. Whereas in a dictionary, like the book dictionary, we have these words and their definitions. With a hash, we have their keys and their values. In a dictionary, when we want to know the definition of a word, let's say we're looking up phone, we go to the phone entry, and then we can see its definition as the value. In my example, I want to see what is in the key puppies, and in the puppies is Matt, right? And so we need the key in order to retrieve the value. Questions so far about hashes? This is all very theoretical, just lots of words so far. We're going to show you like how to use that in like real code in a little bit. But Ida?
So keys can't exist without a value?
Yes. That's like a that is strangely a more philosophical question, and you probably probably realize, like, if you call,
Oh, I'm super deep.
Okay. It's like this. If we have a hash and we try to access a key that does not exist, it will give us nil back. And the philosophical question is around, what is nil? Is nil something? Nil is nothing, but it's still something. There's, it still exists. It's just like, is the idea, is 0 something? Like, yes, 0 is something. So yes, in one regard, but no in another. Does that answer your question in a way that makes sense? Hopefully.
Yes.
I don't want to get into too much of the philosophical debate of if nothing is something, but
Could a hash value be like an empty array?
Yeah.
Okay.
It can be anything. We could literally, much like you could put anything inside an array, you could put anything inside a hash, right? We could have an array full of empty arrays. Like, that is still a thing. Isaac?
Will you show us how to convert this fridge items one array into a hash?
Yes, not exactly. We'll show you how to manipulate it, and we'll be able to see that. There is no easy conversion from array to hash. So I'm not going to show you like how to do specifically the fridge items one, but we'll see how to construct a hash. Yes.
But I want to see how to convert this.
I mean, you'll
Will
see.
you
You'll see.
please just show us?
If we have time, we'll show you how to do that. Cool. Other questions? Cool. Let's move on. So so a hash is enclosed in curly braces. The squiggly ones that are above the square brackets. Key value pairs are separated by commas, and keys and values are separated either a rocket or a colon. So we're going to give you kind of an example. One note I want to make, super important. Each key in a hash must be unique. And so why this is like, let's say, I think it's the same reason, like when we think about it, like phone numbers, every single phone number has to be unique. Like I cannot have the same phone number as someone else, because like when you're trying to access that phone number, I'm like, who you calling? Like, which value do you want? There's no real kind of way to kind of address that, right? And so we can give you examples here. Let's give an example. Let's say I have example, and I'm going to have a local variable example. We're going to set it to a hash, and what we're going to do, string value use the hash rocket. This value is just a string. Right? And so this here on the left-hand side is the key. And this here on the right-hand side is the value. So what we've essentially done is you create a hash where the key is string value, and let me just, I don't want to use words and conflate things. See that? I just don't want to reuse words and just like getting mixed up in the words. What we've done here is we've created a hash where the key is pizza, and that is a string. And the value for it is, this value is just a string, which is also just a string. And we've taken that hash and we've set it equal to the local variable example, right? And so this is a hash for just one key value pair. We can add more to it. I'm just going to enter a couple times to give myself a space. I'm going to put a comma here because we use a comma, because we see it right here. It says key value pairs are separated by commas. And I'm going to tab over so it's a little easier to read. And we could just do like arrays, Chipotle, and we're going to make an array of 1, 2, 3, stuff, other stuff, true, hello. And this is just me just making an array with just random data types, all different kinds, because we could put any kind of data we want into an array. Right? And now this is the example hash is a hash with two keys, pizza and Chipotle, and their corresponding values are that string up top and that array down below. I also want to demonstrate that keys don't have to be strings. Right? We could have a literal integer as the key, and we'll just, the value is just a string. And we could just do, oops, I need a This should be false. Just remember, we need to have that closing braces there. And so what we've done here is we've created a hash of 4 very different keys and 4 associated values. And this is generally the basic way that we can create a hash for us. Questions so far? Weston?
Is there convention or best use case for formatting the key?
Usually we're going to want to use symbols, which we'll talk about later. But literally do whatever you want. Cool. And so, oh, Ryan?
Are symbols faster?
Yes. A symbol, we'll cover that in a little bit. A little later today. All right. So we've discovered how to put things into hashes. Now let's talk get them out. Food equals, we'll make a new hash. We're going to call it pizza. And it's going to have pepperoni pizza. We're going to make the key here is pizza. The value is pepperoni. If I want to get to access pepperoni, I would do so using the bracket notation. So this would be food, square bracket, pizza, and this would give me pepperoni. And what I'm going to do is going to open up a pry here and kind of show you the thing. Boom. Copy and paste that. You see that? I've made the hash, food, bracket, pizza. Returns me that pepperoni. That sweet, sweet pepperoni. Pepperoni is my favorite pizza topping. It has to be good pepperoni. There's only 3 proper kinds of pepperoni. There's like the standard pepperoni. You have the little one that curls up. Those are the only 2 acceptable kinds of pepperoni. The really like massive, like this size one, look, that's not pepperoni. That is a abomination. Cool. So now that we have this idea, a general idea of hashes, like how would we want to structure a hash to hold our fridge items? What do we think? JJ, thoughts?
I was literally going to say, can you please repeat that question?
Sure. If like, so thinking about the fridge item stuff we talked about earlier, right? How do we want to restructure that using a hash? What advantages can we leverage from having this hash that will make that easier to work with?
By creating keys for each item, and then a value is going to be how many of each you need.
Yeah, that sounds good, right? Like instead of doing, how many eggs were in this thing? 6 eggs, 9 tortillas. We would just have a key milk 1, the value is 1, a key eggs where the value is 6, avocado twice, tortilla 9 times, right? And this is a lot easier to kind of process. Cool. All right, it's 2:27. Let's take a break. Let's be back at 2:33, and we'll continue our exploration of hashes. Volunteers? Ryan?
And associative dictionary.
So I think you're muted for the first part of that. Can you start over for us?
Associative dictionary.
Say more.
Okay, well, so like in a dictionary, we're looking for the word, and the word has this definition behind it, and the definition can be defined as like the information of the hash of that key
Mhm.
and or symbol. And
Cool.
yeah.
Fantastic. Great. Thank you. Awesome. Let's let us push on in this world of hashes. So we've talked about hashes, we defined them, we kind of like talked about like how they could be good. We used that refrigerator example to say like, hey, wouldn't it be better if we stored stuff in this fashion? But let's talk about it in terms of code. There are a couple of ways that we can create a hash. The first is what we've seen. What we can do is that we can do new hash, and we can set that equal to empty pair of curly braces like that. And then what we've done here is we've created a hash, and we have set that equal to the new underscore hash local variable. Fantastic. That is definitely a thing that works. But there's more. You could also do this. New hash equals hash.new. Does the same exact thing. The one wrinkle is that we can use the syntax of hash.new to pass a default hash value. So let's say we do this. So new hash, right? That's an empty hash. And to kind of answer someone's question earlier, I think it was Ida, about like what happens if we have a key, right? We're just using the key. So let's say new hash, we have the key, burrito, not Norito, burrito, because that's what I'm having for dinner. I made a lot of burritos yesterday. And so like we have never declared this burrito key for this hash, right? And so when we enter, we see that this returns us nil. Right? Because it has never seen this key before, it is going to presume that whenever we do this, we access a key that we've never done before, it's going to be nil. However, we can set default values for a hash. And we do that with this new hash, this hash.new syntax. New hash equals hash.new. And I want to pass the 0 because the 0 is what I want that to be. And now when I do new hash pizza, right? Because we've never seen pizza before. It doesn't know anything about pizza. It returns us a 0. And any key we access that we've never done so before is going to return us that 0. This is a useful thing that you may need later down the road. However, we can also still override this. Let's say we can do new hash pizza. We're going to set that equal to pepperoni. Got pepperoni on the brain, right? And now when we do new hash pizza, that returns me pepperoni. But if I do new hash dumpling, I can go for some dumplings right now. That's still going to be 0, right? It's going to presume that anything we want, any key that we've accessed we've never accessed before that we've not explicitly set, is going to be that 0. So Ida, what happens when we pass something to hash.new? What happens there?
It gives that value to everything
Mhm.
that's nil. Like it makes that the default value
Yep.
assigned to keys.
Excellent. Default value was the word I was looking for. Great. So this is how we can create a hash and set it to a local variable that's completely empty. However, as we've just seen in our notes, we can also create a hash with some initial values. And I'm going to copy and paste this from the lesson plan because you don't want to watch me type all the time. And so what we've done here is that we are going on a trip and we have a suitcase hash, and that suitcase is going to carry 4 pairs of socks and 1 pair of jeans. And it uses the syntax where we have these curly braces, we have the key on the left-hand side, we have this equal greater than symbol, equal greater than thing, and the value on the right-hand side. The equal greater than is called a hash rocket. And that's just a way that we can create a hash with some initial values to start off with. Cool questions so far. Weston?
Yeah, so I just want to double check that I understand this correctly. But when we set a default value for a hash, so hash dot new 0, every single never before seen key will default to 0, correct?
Yes.
Okay, just want to double check that.
Yeah, it's I wanted to like be very specific what happens. What it does is it kind of keeps that in mind as a default value. It does not go and create a key for every single possible value there is and put a 0 in it, because we can imagine that is like potentially near infinite and would take up a lot of memory. It just remembers the one time and it's like, hey, if there's something I've never seen before, I will use this instead of no. Right. Just want to make sure that like that is what happened, because technically, like functionally, the two things are the same, but like how they actually work on the computer are two very different things. Matt?
Just checking, but like since it's the last item, we wouldn't need the comma after the 1, correct?
Yes.
It doesn't change anything either way.
Yeah, that's a good catch. Like there is that extra comma in there, and it will work with or without comma. The reason why, because they realize that, like, like sometimes you're gonna forget that there's, you'll forget. It's just a human thing, and they figure this is a mistake humans are gonna make. So let's just make sure that like this works out of the way. But yeah, so I can actually do that again. I could do suitcase equals bracket socks 4 comma jeans 1 enter braces, same thing, right? Yeah. And also like some people argue like it looks prettier if they all have commas. Like I'm very torn. This is on the one hand, I appreciate the fact that it looks pretty when all of them have commas, but like the grammatarian in me is not happy with that comma. So yeah, I have no preferences what you do. It works either way. Cool. Great. Other questions at this point? All right. So, Kevin?
Yeah, for the default value, can that be any data type?
Yep.
Okay, just wanted to make
sure.
sure.
Yeah, the value of a hash, the values in a hash that belong to a key can be of any data type, much the same way that the content of an array can be essentially anything. They work the same way.
Cool, thank you.
Question. Yep. All right. So what we're going to do is that we're going to give you a little bit of time to practice. Let's take 15 minutes. I'm going to post a task for you to do in your Code Help channel. We're going to take 15 minutes to do this. Essentially, we're going to take the suitcase hash and we're going to experiment and do some things with it. One of you should be like kind of pairing using that driver navigator pattern we talked about previously. But I understand there are some of you are triplets, so that might not work out well. But like try to take turns and be fair. But like one of you should be actively doing the typing and the other should be navigating. Any questions about this task? And I shall put you back into your breakout groups. If you do need assistance, just ping me on Slack and I will be into your room to help. But we'll take 15 minutes to do this. And off you go.
We were going through the exercises, and when you're using keys on a hash, you're calling the method keys on a hash, it should return an array, correct? Yeah. We weren't getting that. Maybe we just weren't writing the right.
Maybe we'll make sure we take a look at that when we get to that.
Okay.
Cool. All right, remind me if I don't bring this up, if I forget while we're doing that. Let me pull up my notes. Cool. All right. So we have this hash suitcase. Check. We have 4 pairs of socks and 1 pair of jeans. I was reading an article about proper jean maintenance, how you're not supposed to wash them unless they smell really bad. And that just feels like, that doesn't feel right to me. But cool. So the first step is to add 3 shirts to my suitcase. Ted, what should I do to add 3 shirts to the suitcase?
You're going to want to,
What do I type?
one sec.
Mhm.
So you're going to want to shovel them into,
Yep. Tell me what I should type here.
okay, one sec. We had it up and then I totally lost it. And so I would say suitcase to an empty hash equals empty hash, and then
So,
shovel.
but we're trying to add it to its existing hash, right? Because we don't want to lose our socks and our jeans. Because with just 3 shirts
Oh,
on
so it's-
vacation, we'd be Pooh Bearing it. And we don't want to do that. I think that might
So-
be illegal in most places.
It's a suitcase, and then it is brackets,
Uh-huh.
and then we're going to add we're gonna put shirts in
Uh-huh.
string
Yep. And then
and close the bracket, and
Yep.
then you're going to set it equal to 3.
3. Cool. And now we've done that. It returns as a 3. I'm going to type in suitcase, and we can see that now our suitcase holds the socks, the jeans, and the shirts. Fantastic. Let's see here. Kelsey. Swimsuit. What do we do?
For swimsuit, we're gonna do a similar thing.
Uh-huh.
We're gonna do swimsuit bracket.
Tell me what's the type. Where I am now. What should I be typing?
Suitcase.
Yep. Suitcase. Yeah.
Yeah,
That's
suitcase
it.
bracket.
Bracket.
Okay. And then we're gonna type in swimsuit.
Oops. I need the things. Nope.
In bracket
In bracket. Yep.
equals true.
Cool. And I'm going to type in suitcase again to make sure we've done the thing. Fantastic. Ooh, here's the tricky one. How do we get rid of the socks? Well, we decide that we're going somewhere tropical. We don't need socks. We're just going to wear Crocs all the time, I guess. Let's hear from Kevin. How are we getting rid? We're going sockless. We are subjecting the world to our feet. What should I type to get
Are we
rid
just
of the socks?
Are we removing all the socks or just one pair?
You know what? We are going to be bold. We're just going to be sockless. We're just going completely sockless. What should we do?
So you should type suitcase, and then in bracket, you can do socks, the string socks. And you should be able to set it to 0.
Yeah, suitcase socks zeros. That totally is a thing we can do. I think that we could also potentially set to nil. That works as well. That's perfectly cool. Fantastic. Henry, how are we checking our jacket count?
You would type suitcase and then in brackets, jackets in quotes. And then that's it.
And we don't got jackets. We're going somewhere nice where we don't need jackets. Fantastic. For shirts, it's going to be the same thing. We're using the key string shirts to get that 3 back. Weston, question?
Yeah. So let's say we're removing the socks from the suitcase, and instead of setting it to 0, we set it to nil.
Yep.
Does the key still exist in the set of keys?
Let's find out. Let's do suitcase, right? Not suit cause. Suitcase. We see that. And let us do suitcase socks, right? Equal to nil, right? And we access suitcase, and we see here that it does. It'll still kind of persist there because it's like something, it presumes that because we've kind of interacted with it directly, we want it to kind of still live there explicitly. Yeah, but that's a good question. Kelsey?
Yeah, could we have just deleted it if we didn't want it to exist in there at all?
That's a good question.
I mean, that's what we did in our group, so it works. I just was
Yep.
wondering. in
So how?
case-
So tell me, what did you do in your group that worked? Tell me what to type.
We did suitcase,
Uh-huh.
dot delete,
Uh-huh.
and then yeah,
Friends.
parentheses,
Uh-huh.
yeah. Socks,
That,
yep,
and then we do suitcase, and there it is gone. So that does definitely, essentially, it's similar to what we said before. Functionally, like the same thing happens, but like there is that little bit of distinction between the two. Yeah. So like that is a 100% valid approach as well. You could definitely do that. Cool. Thank you for pointing that out. Cool. We did the shirts, and go back to Ozzy's question. I want to do suitcase dot keys. And that works. I have the jeans, shirts, and swimsuit. And we do the suitcase dot values, and that'll give me an array of the values. Ozzy, I don't know what I might have done differently from what you did, but like it does seem like keys is returning me that array of strings.
Yeah, I think I wasn't doing it in Pry, and so we might have just been, we're putting it, so that might have been what it was.
Potentially that could be a thing. Cool. Any questions here so far? All right. So like as we've seen here, we've used this square bracket notation to access things that are inside our hash, very similarly to how we did that with arrays, right? With arrays, we use the index location, which is number starting with 0. And here we're using the keys in lieu of the index, right? And so again, keys and values can be any kind of object, and we get rid of things. And I think the next thing I want to talk about is iterating over a hash, right? Now, when we have this array here, take this, I'm just going to put it down here. When we have this, how would you want to print these things to the terminal? If we want to print out our entire array here, what would we do? What tool that we've talked about previously would we use to kind of print everything out? Andrew P., what would you do if you need to print out these to the screen?
Just the keys or the values or all of them?
No, this is just an array. So you just want to print out
array?
the, yeah.
So what you could do is you could use clothes dot each, and
yeah,
I mean it's a complicated way.
Yeah, that's we can use each. Yep, that's all we're looking for, right? And that's very easy for us, right? Like we've done this a couple of times already. We'll do that clothes dot each do item sounds like reasonable. Then we do a puts item, oops, and like that. Right, and that will simply kind of just iterate through each item in this array and print the thing out. And we can do this with hashes as well. And what we do is that we do have to change the syntax of our each here. And what we're going to do is that this block parameter is going to take two things, the key and the value. So let me go back here. I have suitcase, right? We got the jeans, the shirts, and the swimsuit. And essentially what we've done here is you create a structure where the keys are the keys are our whatever clothing type it is, and the value is the quantity, right? So what we can do is we can do this. Suitcase dot each do. And so in the pipes, in this block parameter, the first thing is going to be the key. The second thing is going to be the value. So this is going to be item quantity, right? Because the keys of this hash are the items and the quantities are going to be the values. With the exception of the swimsuit, we'll just pretend that the swimsuit's going to have is true, right? And then we could do puts I need quantity item. And we can see here that it says I need 1 jeans, I need 3 shirts, I need true swimsuit. Right? So this is like the difference here is that when we're using each to iterate over a hash, you're going to need to set 2 block parameters because you're going to be working with the key and the value. So you need essentially a handle in order to interact with these 2 separate things, and that's how we do it. Questions about that? About iterating over a hash? You're just going to need to practice. It's just something that needs to be practiced.
Can we do the map method on the hash?
Yep. It works the same way, except like for this particular example, we will not use map because we are not modifying. We're not trying to build a new collection. We're just iterating through everything. Cool. Now we're at this awkward point where we're like kind of close to Pomodoro break, but we're almost kind of close to the end. So I'm going to say, let's just keep going and we'll just finish early instead. If that is okay with everyone. Fantastic. All right. We're going to talk about the thing that y'all were talking about at the beginning of this lesson. Symbols, right? And the way I would describe a symbol, a string that cannot change. And so we could do like thing equals hello there. And thing is the string. And things that we can change the contents of this at will, like hello there can be, we could do thing dot split that, and that combines it to, that turns it into an array of 2 things. But we use symbols because they cannot change. They are more efficient. And we can recognize them because they start, we have a colon, right? So like this here is a symbol. Symbols can have underscores. Symbols can be in quotes, but don't do this. You may see it. I've never actually seen anyone put a symbol in quotes. It's just kind of weird. Just the kind of like, I guess the reason you put a symbol in quotes is to preserve the spaces, but like avoid kind of doing that. And so the reason we talked about symbols being more efficient, because the thing is that because symbols are immutable, and when I say immutable, I mean it cannot change, each symbol can only have 1 object ID. 2 strings that are equal to each other are still separate objects, right? And so let me do this. right? We'll do symbol, oops, symbol 1 equals pizza, right? Symbol 2 equals dumplings. Soup, for the record, soup dumplings are like some of my favorite things in the world. And so what we do here is that an object ID is a unique identifier for an object. And so like more disparate objects will not share them. So when we do symbol 1.object ID, it will tell us its object ID. And we see that's just the number, blah, 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 blah. And I can go back here and we can do symbol 2, and we see that symbol 2 has a different object ID. What these IDs are, the numbers are immaterial. We just need to know, like, hey, these are different things because they have different different numbers associated. Much like the same way, like my computer may be the exact same kind of computer as yours, but they're different because mine has a different serial number, right? And so what we can do here is that we can take string 1 equals string pizza, right? And we can do string 2 equals string pizza. Can we not say that these are essentially the same thing, right? They're both the string pizza. String 1 dot object, not Boject, object ID is 200. String 2 dot object ID is 220. And so what happened is that when, even though the string is pizza, is still pizza, essentially we have one object sitting in our memory called is pizza, and another string sitting somewhere else in memory called pizza. And we can kind of do like, we could probably do simulate the same thing by sim1 equals pizza, sim2 equals symbol pizza, sim1 dot object I is that number 21999708, but that should look familiar. Isn't that the same up here? And if I do sim2 equal pizza, sim2 dot object ID, same number, they're still referring to the same exact object. So this is why symbols are going to be that more efficient. They're going to be they're faster for many reasons, faster comparison wise, because in Ruby, if you're comparing two strings, it will go through character by character to see if there's a match. Whereas if you're comparing two symbols, Ruby will do just a look up at that object ID, and that's a lot faster to do. And so we generally want to use symbols for our keys when we're working with hashes because it's just a little quicker, right? And so we had our good old friend, let me grab my notes here. Where are you? Where are you, Suitcase? How did I lose my Suitcase? There we go. Previously, we had this, right? This is how we created our words, our hash with string keys, right? But we can convert that to, not convert, but we can use instead symbols. And that would look like this. Be socks 4, comma, jeans 1, and that works. But that's like, there's like the hash rocket. That's just, why would I even have a hash rocket? So what Ruby does is it gives us a thing called syntactic sugar. And syntactic sugar is kind of like this shortcut that just makes it makes life easier for us that we can use. So this here is you're creating a suitcase hash where the keys are strings. This here is you're creating a suitcase hash where the keys are symbols. I'm going to show you another syntax where we can use symbols as keys. Like that. That's just a lot easier because you're not dealing with the hash rocket. Most modern versions of Ruby like the syntax. I don't think this works on very, very old versions of Ruby. But it should be old to a point where you'll probably never use it. But essentially this is the standard syntax for creating a hash where the keys are symbols. Quoi?
It's Koi.
Oh, sorry.
No, you're good. So when you're calling the key with like the square bracket,
yep,
between I guess the second and third one, which one would you use? Like this, the colon in the front, or in
when I'm calling it, when I'm assigning it, or when am I calling or getting it?
So like when you're trying to get the value from that key.
I would do this. Whoops, nope, not that.
Okay.
I'll do that.
Cool.
We just move the colon over when we're assigning. Because it kind of makes sense. I don't know. It's kind of hard to say. Like I kind of explain, but like it just makes sense. Like when the colon's at the end, it's like, yeah, we're just putting that into that. And by the way, this is a symbol, right? Cool. Whereas this is like a little more typing, a little stranger.
Yeah.
Yep. Cool. Other questions? Ted?
So I think if I remember correctly, our tests, the expect is going to look like the opposite, the output for the hash for like this, the colons.
Can you reword that? I'm not exactly sure what you're asking.
So I guess the output is going to be the opposite for the colon. When we do like an expect for like a test.
No, it would be the same. Like we would I would do something like expect suitcase socks to equal 1. Yeah, like that.
Okay.
Cool. Ozzy?
How does the 2H, like 2_H method work? Like, and can you pass, like, can you use an argument to associate a value to the associated value?
Yeah, I'm not a fan of using 2H. Like the idea is that 2H is designed to convert a array or some other object to a hash. Elements of integer at 0. Let's try this. Yeah. It wants an array of arrays. Yeah. Yeah, so what this will do, this is going to be, we're going to do stick an array of 1, 0, A, comma, 1, comma, E, oops. C, oops. Right. What it does, it takes an array of arrays and then it will take it'll convert into a hash doing that. I'm not a fan of 2H. Like I don't like doing it that way. like because like on I think I don't really use 2H because I just don't find myself getting data in a format like this. 2H is a method like, well, you need to have data coming exactly like this way, and like the output of where the first element in the sub array is going to be the key and the second element is going to be the value. Like that's how the information has to go in, and like once in a blue moon, that's how you're going to get it. But like, does that actually happen? It's never happened. It's never happened to me personally, and I've never used 2H. I've always ended up using iteration to build hashes in other ways. So like 2H, it would be a great tool to convert this nested array structure into a hash. But like, to be honest, like I would not, 2H would not have been my first reach. I would have probably just used each to start with to build a hash like one by one, because I would not have remembered what 2H did, because 2H is just such a narrow kind of thing to build out.
And then what's the easiest way to set an array as the value for a new hash?
As a default value?
Yeah.
That should work. Like that. Cool. Rowan?
Can you change the key name that corresponds to a value, or would you ever want to?
Oh, that's a good question. You know what? Cool. Probably you'll have to. You probably may have to. I can't, like you'll probably have to do anything. I don't know off the top of my head. So like quick Google, how to change a key in a hash Ruby. Looks like we've got Stack Overflow. Great. Stack Overflow. Ugh. It's like the Mos Eisley Cantina. That's kind of like, yeah, you do it that way. Imagine there are parens in here. So essentially, when you delete a key, the return value is returned. Delete returns the return value of whatever was in there, and then you can now immediately set that to something else. Is that true? Let's take a look. Suitcase. Hello, suitcase. Suitcase.delete swimsuit. If this returns a true, then we know that that works. Yeah, it does. So let's say, so we could do suitcase. We've decided that we are going to be fashion forward. Suitcase, we're converting our shirts into tank tops by cutting off the sleeves. Tank tops equals suit case dot delete. That's a great question. And now we go to suitcase. We see that we've converted our shirts to tank tops. Fantastic. That's a great question. Cool. All right. All right. So for the rest of this time, what I'm going to do is that, oh, Ted, sorry, Mr. Hand.
So I'm not sure how to ask this, been like trying to fight in my head how to ask this, but it's like, what's like the best way to learn how like hashes interact with the arrays? I guess like in one of the exercises we had, there was like a method called like new that you would find in the Ruby docs to figure out the problem, like for the practice I see. Like, how would you figure that out without like asking someone else? Or like, I tried Googling it a bunch and I couldn't figure it out. Or if I did, maybe I did some of it like you did with your Stack Overflow post, but just didn't understand it. So I guess like, what's the best way to start out with?
Yeah. So I am a firm believer that you don't know how something works until you really fuck with it, like fuck up with it. So like when I started learning Ruby, hashes were hard to me. Like I had a lot of trouble with hashes because like they are, like I kind of talked about earlier, it's like it's just not, this idea of a key value store was not something I was ever really thought about, learned in school, etc. So what I did, and this is I call this a best / worst / best idea, was that I tried to use hashes to do everything. Very much like when you have a hammer, all the world you see is nail. You try to make hashes do things that they should never be used for. And in doing that, I learned what I could get away with hashes. And I think more importantly, though I did learn what I could use hashes for, I learned what I should not use hashes for. So I think that if you really do not have a good handle on hashes or want to get better at hashes, this is just like, just use them everywhere. Like, just like, don't eat, like, use them every chance you get to solve every problem you get. And there's a point where you're like, okay, I really kind of get like how these work inside and out. And then you can go back to like using the most appropriate kind of thing to start with. That I think that like use that process of using a hash literally for everything was what really got me over that hump of like, why would anyone want to use a hash? This is stupid. Because I think that like beforehand, like I would just use arrays for everything because arrays are easy. Not easy, but they're easier to understand in my head for me anyway. And I would use arrays to do things, and like I would start using arrays for things that like I shouldn't use arrays, and that's how I really got to know arrays really well. And so like at one point I was like, no, I need to learn hashes, and so I just used hashes for everything, and I learned real quick.
Do you have like a quick, like, you don't have to do an example, but is there like an example that you can like say that we would try to go out of our way to use hashes for, to get as a practice kind of thing, like an example of what you're talking about? Like you don't have to actually work through it.
I can't. Go through the practice ICs and just like don't use arrays, use hashes instead, and see what terrible things you get up to in doing that.
Okay, sure.
Right, like that, yeah, that's gonna be the simplest thing, the simplest way to like get someone practice, right? Yeah, there's no faster way to learn than like to try to make something do something it was never intended to do.
Thank you.
Cool. Yeah. Cool. Anything else? All right. So at the end of this lesson plan, the link is in your Slack channel. There are some practice stuff, some extra exercises. I highly suggest that you start them and do them before you start working on your project for the rest of the evening to familiarize yourself with hashes. But that is it for today. Let me stop recording.